In this lesson, we're going to go over some of the big ideas from grade 9 about fractions, working with fractions, operations, making them bigger or smaller, and then just get started on solving problems that involve fractions. Call that proportional fraction. So first big idea, mixed fractions. So what happens when you have a mixture of whole numbers and fractions? Well, we don't really like them in high school math, so we usually turn them into improper fractions. You get an improper fraction when you have a bigger number on the top. Your numerator is bigger than your denominator. You might recall from grade 9 how to convert fractions. Okay. The quick way is, okay, we're thinking to ourselves, we've got a whole bunch of ninths here. Well, 2 is a whole number. I'm going to turn that into ninths. So how many ninths is 2 worth? Well, that's 9 times 2. That's worth 18. We already had 3, so we have to add the 3 on top. We end up with 21 ninths. And you probably saw that we multiply by this, and then we add that piece. Okay. Like all videos, my suggestion is at some point you pause some things, try them yourself. So maybe try the next one yourself, see if you get the right answer. I'm thinking about quarters in this case. So I got to turn my 3 into quarters. 3 times 4 makes 12 quarters, plus the one I already had on top would make 13 quarters. Okay, and the one that usually gets us at the end over here, we're talking about eighths. The part that usually gets us is this negative sign. It doesn't actually affect your conversion. All it tells us is the answer is going to be negative. Okay. We still do the exact same thing, so I got to turn my 2 into eighths, 16 eighths, plus one more would make 17 eighths. It just happens to be a negative sign, because it's a negative value. Okay. Idea number 2, reducing fractions. Often in math, we get big numbers. If we can make them smaller or easier to work with, we want to do that, especially when it comes to fractions. We can do that by dividing both parts of the fraction by some number. Now, you do have a button in your calculator that would help you do this, your fraction button. If you know how to use it, I have no problem with you using that. It usually looks like this, your ABC button, or it might even look like, depending on how fancy your calculator is, literally a fraction. Okay. Probably something you need to ask your teacher about, so come in and see me, and we can go through how to use that button yourself. If not, we can do this by hand. 2/10 can be reduced because it can divide both of these numbers by 2. And if I do that, I get 1/5. It's just an easier version of the same fraction, a nicer version to work with. Okay. Like the one on the previous screen, when you have a negative, just write down the fact that you have a negative. It doesn't actually affect any conversions here. What can we divide 12 and 32 by? Well, they're both even, so we could divide them by 2. If we do that, we get 6 and 16. But notice, those are still even, so we could divide them further by 2 and 2. And our lowest version of this would be negative 3/8. Now, could you do that faster? Absolutely. In your brain, maybe, hopefully, you think to yourself, I can divide that by 4 and divide that by 4. That'll get me right down to this answer right off the bat. When you're finding that factor you want to divide by, try and pick the biggest number you can divide both things by. We'll try the next one. 9 and 12ths. Ooh, we got this negative sign in here. So I'm going to pause and talk about negative signs for just a second. Okay, if I had 1/2, 1/2, and 1/2, you would probably tell me, hey, those are all the same number. They're equal to each other. Well, something else is similarly true. Negative 1/2 is the same as 1 over negative 2, or the negative of 1/2. We consider negative signs to be portable. You can put them on the top, the bottom, or in front. You have to decide which makes the most sense in your brain. Now, personally, I don't like it on the bottom. I like it on the top. So I'm going to put my negative sign down right off the bat, because I know there's a negative sign, and then I'm going to reduce my fraction. What can I divide 9 and 12 by? They both divide by 3. We'll get 3 quarters. Okay, last one. I got a negative on top. I like it where it is. Ooh, 52 and 13. That's a tricky one. So maybe I need my calculator for this one. Maybe I don't know what I can divide 52 and 13 by. You may have to guess and check a few numbers. You may have to ask yourself, well, Can I divide by 113? Doesn't divide by much. Let's try dividing it by itself. Can I divide that by 13? Of course. How about this one divided by 13? And yes, you can. It comes as -4 and 1. And while that is a fraction, mathematically, would it not be better to write this as just a whole number? If you end up with a fraction over 1, you don't have to put the 1 there. You should remember there is a 1 there, but you don't actually want to write the 1 there most of the time. Whole numbers are easier to work with than fractions. All right, number 3, big idea. Common denominators. Okay, it's kind of the extension of what we just did a second ago where we were reducing fractions. Sometimes we got to make fractions bigger to compare them to each other. We can do that by finding a common denominator. Something that the bottom can all be the same as. Okay. So if I look at this example for a second, it says right from smallest to largest, there's a whole bunch of different fractions. In my brain, it might be hard to compare those. Well, which one's bigger, which one's smaller? But if I can make them all comparable fractions, I can do that much easier. So I ask myself, what can I turn a 6, a 4, a 12, and a 3 into? If I had to, I could write out a list of numbers underneath these that I could turn these into. So a 3, if I double it, 6, 3 3s is 9, oops, 3 3s is 9, 12, 15, and so on. 4s, I can turn that into an 8 if I double it, 12 if I triple it, 16 if I quadruple it, a 6 if I double it, if I triple it, if I quadruple it, 12, a 24, a 36, and so on. I'm looking for something that there is common to all of these. If you notice, number 12 shows up in every single one of them. So I can turn them all into 12s. And I'm going to do that. I'm going to write them out as a common denominator of something over 12. Now this one is already a 12, which is my third one. I'm going to put it right there. I don't have to worry about that. When I convert a fraction to something bigger, like reducing where we divided both things by a number, now I'm going to have to multiply by a number. Because to turn a 6 into a 12, I had to times by 2. So I have to times this by 2. To turn a 4 into a 12, I had to times it by 3. So I'm going to times this by 3. And turn a 3 into a 12, I had to times it by 4. So I'm going to times it by 4. And now I have comparable fractions. Is it easy to put them from smallest to largest? Sure it is. Which is the smallest? This one. What did that number used to be? That was 1/4. That's the smallest of those ones. Next one was the 4/4, which is actually 1/3. And then we got, well, a 7 comes next. That's smaller, so 7/12 was 7/12. And last but not least was the 10, but technically that was 5/6 when we started. There's my smallest to largest. It's the idea of reducing fractions, but in the opposite direction, making them bigger. We actually call these equivalent fractions. They're equal, but different. Okay, let's try a couple quick operations here as fractions. We'll start with the easy ones. Multiplying and dividing. Multiplying is the easiest because all you have to do is multiply. Just make sure you go straight across. There's no common denominator, there's no funny business here, just go straight across. Before you do that, make sure you get rid of any mixed fractions. We don't like those. And at the end, if you can, reduce things to the lowest terms, make your fraction nicer and easier to work with. We'll start with a nice one to begin. So we've got 3/2 times 6/5. That's straight up multiplying. So I have no mixed fractions to worry about. I can go straight across. 3 times 6 makes 18. 2 times 5 makes 10. Can I reduce that? Yes, I can. If I divide them both by 2, I get 9/5. That's it, that's all. If we try the second one, maybe you guys want to try this one. A little bit trickier because you have that mixed fraction, but we talked about how to do that already. I got to turn these into quarters. Well, I need quarters times 2. That's how many whole numbers I have. That's 8. Plus the one on top, that gives me 9. Ooh, a negative sign, I'm going to move it to the top because I like it there better. And now I'm going to go straight across. 9 times -2 is -18, and 12. Can I make that easier? I think so. I think those both divide by 6. So I'm going to do that. I'll have -3/2. And ready, that's multiplying. Just go straight across. There's no tricks to multiplying. Let's talk about dividing. To divide fractions, I'm going to turn it into multiplying. I can do that by finding the reciprocal of the second term. Reciprocal, in case you forgot, is just the fraction flipped upside down. So if you had 2/3 and you flipped it over, you'd have 3/2. So what does that mean when we put it together? Well, let's take a look at this first example here. I see dividing, so I'm going to find the reciprocal of this. I'm going to flip this one upside down. First one stays the same. The second one flips upside down. Don't change numbers, don't change signs. It's still negative in there. But now we're going to turn this into multiplying. We know how to multiply. We just did that. -4 times -3 is 12. 3 times 2 is 6. Hey, 12 divides by 6 really nicely. That's just 2, a whole number. You guys can try one. I see dividing, so I'm going to turn to multiplying. The 6, technically, you can put the 1 in there if it helps remind myself there's a 1 there. We've talked about that earlier. We're going to turn this into multiplying, so I'm going to put the 5 on the top and the 4 on the bottom. It's got a negative sign. We've also talked about that. They're portable. Put it where it makes most sense to you. I'm going to put it up top. Okay, multiply straight across. We got 30. 1 times 4 is 4. I can divide them both by 2, and we think we get 15/2. That's it. There's dividing. No real tricks there either. Okay, adding, subtracting. Usually the tricky ones. But we've kind of already reviewed what to do with them. To add and subtract fractions, they have to be like things, as in common denominators. If you don't have a common denominator, you can't collect the things together. So we're going to have to fix that. As usual, we're going to get rid of any improper fractions or mixed fractions. Don't like those. As usual, we're going to simplify it. So really the only trick here is I need things that can go together first. So I say to myself in this first example here, I got thirds and I got ninths. Those aren't the same things, but I can make them the same things. I can make something smaller into something bigger. 3s, if I double it, could be a 6. If I triple it, could be a 9. Hey, that's a 9. That's a 9. That's a common denominator. How did I turn a 3 into a 9? I tripled it. I times it by 3. If I do the same thing to the top, which I always have to do, I get 6 ninths. Now I'm just collecting the things that go together. I'm collecting my ninths together. I got 6 of them and 7 of them, and it makes 13 of them. And this question doesn't reduce, so we're all done. Okay, maybe you guys try the next one just to see if you remember how this works. 3s and 5s. Ooh, what can I turn 3s and 5s both into? I could turn a 5s into 10s or 15s. I think I could turn 3 into a 15 also. So I can write down my common denominator. I have to triple that one, which means I got to triple this one. To turn a 3 into a 5, I've got to multiply by 5. So I'm going to multiply by 5. And I'm going to collect all my 15s together, and I got 10 plus 12, which makes 22 15s. That's it. We'll try C here. I got a mixed fraction. We'll deal with that. I need sevenths. I got 1/7. That's 7. Plus the 6 on top gives me 13 of those. And minus 3/4. Okay. What can I turn 7s into? I can turn 7 into a 14, a 21, a 28, a 35, and so on. 4s, does 4 go into, I think 4 goes into 28. I can turn a 4 into a 28. So my common denominator this time is going to be 28. I'm going to times this one by 4, which means I've got to times that one by 4. I might need calculators for this, that's okay. I'm going to times this one by 7, so we're going to times this one by 7. And this time be careful, we're subtracting. You should end up with 31 over 28. And there's some fraction work. Okay. Last little thing, I briefly introduced this earlier, equivalent fractions. It just means they're equal versions of each other, just different versions of each other. Like when we made things bigger, like here. This, if I And this is actually equivalent to this. Those are the same fractions, just different versions of each other. We turn that into this. That was a different version. We did it by times it by 7. All three of these are considered equivalent fractions, equal to each other, but different versions of each other. Okay. Sometimes we actually want to solve problems involving equivalent fractions. So take a look at this example here for a second. Would you agree that 12 over 8 is actually the same as 3 over 2? I hope so. I can think of this as if I divide by 4 and divide by 4, it comes out to this one. Or vice versa, if I times by 4 and times by 4, it comes out to this one. Right? They're equal but different. Well, there's something kind of cool about this. If we have fractions that are equal, the diagonals, when you multiply them together, we call this the cross product, 12 times 2 and 8 times 3 always come out to the same number. It's a really handy rule because it allows us to solve for a missing value in proportion. So take a look at the next one here, this example here. We're going to solve a question, kind of like introducing algebra again. I don't know the missing number. I could probably guess and check and think to myself, how do I turn a 48 into a 4? Totally would work, but I got a faster little rule for you. Watch this. We're going to do 48 times x. If we do that, that gets us 48 x's. We're also going to do 4 times 36. If we do that, it gets us 144. But I don't really want 48 x's. I want to know what 1 x is worth. So how do I get rid of the 48? Oh, I just divide it back out. And whatever I do to one side, do to the other. And you can hear me say that a lot this year. And it turns out that if I do that, x comes out to 3. These two canceled each other out, and left us as 1x. Now, I'm guessing some of us could probably guess and check in our head, oh, I could have just divided by 12. That worked. If I divide that by 12, it gets me 3, 2. That's great. But it doesn't work so well in the next one, which is not such a nice number. And it definitely doesn't work down the road later on when we have x's multiple spots. So we have a little procedure here we can work with. Let's try this next one, shall we? I want to know what y is. Well, I know if I multiply them together, it should equal whatever that comes out to. And 45 times 8 is 360. But I don't want 32 y's. I want to know what y is. So I'm going to divide by 32. Whatever I do to one side, do to the other. And I think you should end up with 11.25. And now we're solving some problems. And we often see this in the next style of question. It's written as a ratio. A ratio is another way of writing a proportion. A proportion is another way of saying a fraction. And I can turn ratios into fractions by just writing them in the right spots. It becomes the same kind of problem. Maybe pause and try this one yourselves. You should get 5 times x, that's 5x. 30 times 45 makes 1350. But I want to know what 1x is. How about 270? All right, last but not least, our little extension for today. What if we get a triple fraction? The reason we're showing this is it's a skill we're going to need for down the road. How do I solve a triple fraction? Well, you don't. You solve a double fraction. You pick two things at one time and just work with those two. Exactly what you've been doing. So 60 times x makes 60x. 12 times 48 makes 576. But I want to know what x is. So I'm going to divide by 60, divide by 60. And I got 9.6. And there's nothing wrong with decimals. Now, I did say you can't solve a triple, you solve a double. So how do we do the next part? I just pick two to solve at a time. So I'm going to use the 12 and the 60 and that one. I'm going to ignore the middle one and pretend it doesn't exist. So I'm going to do 12 times y and 60 times 7.5. 450 for that one. I want to get y those. We're going to divide by 12. You should get 37.5. Now somebody might ask, well, do I have to use the outer pair? No, you do not. Once you get the x value, you could say to yourself, well, I know what x is. X is 9.6. And I can do this pair with this pair. That would also work. It doesn't matter which pair you pick as long as you know, as long as you are only working with 2 fractions at a time. Okay, that takes us to the end of fractions proportions. We got a practice sheet. It's posted to Edsby, or you can come see me and get it. If you're stuck, come see me, come ask some questions. And away we go into our first unit.